Hello students, in this video I'm going to talk about arithmetic sequences. So first I start with the word sequence. If I have these numbers 3, 4, 5, 6 and the numbers continue forever and the points show that, these numbers are in a sequence. So a sequence is a list of numbers in particular order. Now each number in a sequence is called term. The first term is symbolized by A, and we write this A sub 1. The second term is symbolized by A sub 2. The third term, A sub 3, and so on. A sequence can be thought as a discrete function whose domain is the set of positive integers over some interval. Many sequences have pattern. For example, in the sequence above, for the number of terms here, we have 1, 2, 3, 4 terms showing each term can be found by adding 1 to the previous term. To find that, you take the second term and subtract the first term. For example, 4 minus 3 gives you 1. 5 minus 4 gives you 1. 6 minus 5 gives you 1. So you are going to add 1, 1, 1 in all of them. A sequence of this type is called an arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first term is found by adding a constant called the common difference to the previous term. So one more time, arithmetic sequence is a sequence in which each term after the first term is found by adding a constant called common difference to the first one. Now, we developed in the class the equation which one shows how to find the nth term of an arithmetic sequence. For that we use linear equations, and we went from linear equation to the arithmetic sequence. And we found that the equation is a sub n equals a sub 1 plus n minus 1 times d, when d is called the common difference and is the slope of the line, n is number of terms, a sub 1 always symbolizes the first term. A sub n is any term in the sequence. So we are going to see an example now. How can we write an equation for the nth term? So the question here is write an equation. And it's giving you a sequence 8, 17, 26, and 35. And points shows that the sequence is infinite sequence, is never ending. So from the sequence we have to know how to read that. We know here the first term, which one in this case is symbolized with the a sub 1. So a sub 1 equals 8. The second case is a sub 2 equals 17. To find the common difference, we said take the second term minus the first term. 17 minus 8 gives me 9. 25 minus 17 gives me 9. 35 minus 25 gives me 9. So in this case, the common difference is equal to 9. To write this equation, I'm going to use the equation that I just developed here, and I say a sub n equal a sub 1, which one I substitute with the number 8, plus, and I go n, number of terms I don't know, so I'm going to leave simple n, minus 1 times common difference, which one in this case is 9. Now I have to use here the distributive property to distribute this equation. So I have 8 plus 9 times n, 9n minus 9 times 1 gives me 9. I have to combine like terms, and after combining like terms, I have a sub n equals 8 minus 1 gives me negative 1, so I have 9a minus 1. Now, as you can see, students, this is a linear equation, and this is amazing, and I want you to see how you connect the linear equations with the arithmetic sequences. And from that linear equation, you can tell that the slope here is equal 9, and the y-intercept here is negative 1. And you are smart to know that the first term here is 8, but this doesn't mean that 8 is the y-intercept or the b. in the linear equation. So to find the b I'm talking about here, you have to subtract 9. You do the opposite, which one 8 subtract minus 9 is going to give you -1. And that is real, the b, the y-intercept. So in this lesson, I showed you how to use the equation of the equations of the arithmetic sequence and connect that with linear equation. Thank you so much.